Hello everyone. Today I want to start a new series. It's about DeepSeek. This is one of the hottest topic in the world, not only in AI right now. So I read their DeepSeek technical report, and I want to summarize like why is DeepSeek so good. There are multiple reasons, and today I want to share one of the like main reasons. That is the mixture of experts architecture. Let me start by giving some context. So DeepSeek is a bomb. It's a huge bomb. To be specific, when it released back in December, but when it picked up the popularity and shared a benchmark, it hit the stock market greatly. Nvidia lost 20% of value, and in a single day, I think it lost the largest amount of value in history. And then it also took down the whole AI chip industry, and then affect the whole Nasdaq, and the whole stock market is basically freaking out. Um, so why is it? So there are multiple reasons of it. First, the DeepSeek developers claim it took roughly 5.6 million to train their latest version, compared with ChatGPT, which is 78 million, and Google 191 million. So it's a lot cheaper, and the performance is actually really good. It's on par with OpenAI E01, which is one of the most advanced commercial AI models. So this could change the whole game. This could change the whole logic of how big companies run AI, dominates AI world. So this is the benchmark DeepSeek took. It's comparing with the current most advanced models, uh, uh, and this is doing multiple tasks, including like math and code forces and software engineer benchmark. You can see like the performance compared with the most advanced model is actually on par, and sometimes even better, but the cost is like so much lower. Although it have like short-term wise, it might negatively impact AI chip industry, since the previous logic is all based on the scaling law, right? You invest more in the hardwares, in the scale, and then the model is going to give you better results. However, right now, DeepSeek shows that if you invest in algorithm, invest in the software layers, you can actually improve the effectiveness a lot, and then give you a lot cheaper options. But I think long-term wise, this is actually great to the industry. So I'm very optimistic about this research outcome. So if it's the model, if it's cheaper, then it will be lower bar for new players. Like previously, it's basically OpenAI, Gemini, maybe some few other big techs. So the entrance bar is very high, but now it's a lot cheaper. So there will be more players in the game, and then it's a more competitive market, which means we will have better AI models and better AI applications, which means the industry is going to get more prosperous, and then they will have more demand for AI chip. So you can think about it like if you live long enough, if you still remember like all the previous new technologies, say mobile phones, internet, all of those, it was pretty expensive in the beginning, and not a whole lot of players in the market. But then before it take off fully, it always have the face of needs to be cheap enough. So like there are more players, and then you can find a real like product market fit. So I think like AI is currently in that phase, and I'm optimistic in the next few years it's gonna take off. and all the players in the game is going to benefit from it, no matter it's OpenAI, Google, Microsoft, DeepSeek, whoever's in the player. And in the end, the consumers, the people, is going to benefit from it. So I'm optimistic. So why is DeepSeek so cheap and good? There are multiple reasons, and I plan to use one episode to explain one. So this episode is gonna be about the MOE architecture, which is the mixture of experts architecture. So this is like a overall view, and each MOE layer, you can see it contains a few key components. First is the gating network. You can also call it router. It determines like which expert should I send this token to. And then after the gating network determining which expert it should go to, you reach one or few experts. So instead of activating the whole neural network, you actually only go through a very small part of it. And then you get a result. So this is the architecture overview. So a bit of more details of mixture of experts. So it came out earlier than the famous transformer paper in 2017. It's also from Google. It's interesting. This I could start a whole new other series out of this. As a Googler myself, I find it amazing. Like all the important technology came from Google, but sometimes, or many of the time, Google is not the first player to take the biggest advantage out of it. So anyway, that's for another day. Mixture of expert have the following advantages. So it's pre-trained much faster compared with denser models, and it has faster inference compared to a dense model with the same number of parameters. So as a result, it enables models to be pre-trained with far less compute, which means you can dramatically scale up the model or dataset size with the same compute budget as a dense model, which means it's just cheaper and it can achieve the same level of quality. So as I was mentioning before, MOEs have like two key components. First one is a sparse MOE layers. This is used, and usually in the transformer architecture, it replaces the dense FFN layers. So MOE usually have a certain number of experts, where each expert is a neural network itself. In practice, those experts are usually also FFNs, but sometimes they can be more complex or even MOE itself. The second key component is a gate network or router. So that determines which token we should reach out to. So this is like a more detailed view of what actually happens in the MOE. So on the left side, you can see this is, if you are familiar with how the transformer work, you should you should be very familiar with this. If you're not familiar with transformer, go look at my other transformer series. It's very I think I explained pretty well. So first, the input encoding and position encoding plus word embedding. I went through the self-attention layer, and then it goes through the add and normalization. And instead of going through a feed-forward layer, it goes through the MOE layer, which is, if you expand it, it's on the right-hand side. So there's a router, and there's a few expert layer. And this is an example. There's a sentence. For example, the sentence is more parameters is needed, blah blah blah, and we are we're just taking care of the first two, which is x1 and x2. So this word embedding goes to position and encoding. There's the self-attention. There's the add plus layer normalization, and then instead of going through the FFN as transformer usually do, it goes through the router and determine we should use expert number 2. So instead of activating the full FFN network like what transformer usually do, it only activates a very small subset of it, which is FFN number 2, and then go through the other add-in normalization and gets Y1. Similar, it will go through the similar approach. X2 is the input and Y2 will be the output. So this is the mixture of expert, what usually look like. So DeepSeek use similar approach, but it makes some few modification, and I think it's pretty good at modifications. So they have routed experts, but they also have the shared expert, which means there are a few experts. I think DeepSeek have one or two. Anyway, so they have a few experts that's always there. So the router only route to one of the few other routed experts, but for shared experts, it's always there. So it still only enables a very small subset of the model, but there are experts that always have the context. So I remember the DeepSeek model is like 671 billion parameters, and each expert, I think it's around 30-ish. So whenever you do the inference, you actually, instead of activating the whole 600 billion parameters, you are only enabling activating the 30-ish, and that makes the inference really, really fast, and it also like bring down the training cost a lot. So it's almost like 190 million, like what Gemini does, and then you bring it down to 6 million, less than 6 million. So that's amazing. Okay, so today this is about the first reason why DeepSeek is cheap and good. So the next episode is going to be about MLA. See you next time. Bye.